Hello, good morning. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you everyone for opening and watching this video. For this meeting, I will explain parabolic motion. Parabolic motion is a motion that's through the air that make a curved path, and remember the action is under gravity only. Okay, so for today, for this meeting, I will explain again about parabolic motion with one example, and it has a few questions in here, and I hope from this one example all of the concept of the projectile motion can be explained. So after this you can understand these questions. You can find the solution how to solve these questions. What is the velocity? What is the total time? What is the horizontal range? And what is the maximum height? And etc. All right, let's start. The example, I have a projectile here, and a projectile was shot with initial speed of 200 meters per second, making an elevation angle, not angle, sorry, of 30 degree with respect to the horizontal direction. Okay, first let's draw the axis. And here I have y-axis and also x-axis. And this is the motion of projectile. All right. Okay. So from the questions, you can see that we have initial speed. So in the very first beginning, the projectile was shot with initial speed. So we have initial speed in here, which is initial speed is 200 meter per second. And also the angle in here we have theta, which is 30 degree. Okay, respect to the horizontal direction. Determine the A components initial velocity. Components in here meaning x-axis and y-axis. Component x and component y like vector, okay? So if you have VO in here or initial velocity, then you must make initial velocity in x-axis and also initial velocity in y-axis as well. And for x-axis, it's like do you remember the sin costan vector? Um, soh cah toa. Soh if it's sin, meaning that opposite over hypotenuse, and if it's cos cah, meaning cos is adjacent over hypotenuse. Okay, so because if initial velocity in x-axis is adjacent of VO or initial velocity, so we use cos adjacent, yeah. So VOX equals to VO cos theta. So VO is 200 and cos from 30 degree is half root 3. So the result is 100 root 3 meter per second. And for the component in y-axis, VOY, is like it's vertical like this, right? So it's like opposite of the angle. So we use opposite in here is sin, VO sin theta. VO 200, initial velocity is 200, and sin of 30 degree is half. So the result is 200 times half equals to 100 meter per second. So you have the answer of components of initial velocity, point A. Clear? Now point B. Component of velocity and position of the projectile 5 seconds after shooting. 5 seconds. Let's say when you shot in here, 1, 2, 3, 4, 5. Okay, let's say in here. This is time 5 seconds. And let's say I will put symbol in this dot point B, let's say. Okay, so the question is component of velocity. The component in here meaning x and y. So uh, B in here actually have velocity like this, VB. But again, this is not not exact x, not exact y. So you must making a vector component VBX and VB in y-axis. Clear? Because this is vector, yeah? Okay, so VBX. How much is VBX? Okay, we have assumptions in here. X direction or horizontal, we use uniform motion. So this is uniform motion. Because there's no gravity included in this part, meaning the velocity is constant. So VBX in here is like VOX. So the result, the value is 103 meter per second. Clear. And for in y-axis, because this is in vertical axis, in vertical motion, we use accelerated motion. Do you remember the last formula, linear motion? This one, Vt equals to Vo plus minus Gt. Okay, we use this formula. But let's say final position in here for B. And for initial velocity in here, because this is in vertical, you must use in y-axis. Okay, so how much is Vb in y-axis? Is Vt final in B position equals to initial velocity in y-axis, because this is vertical and because it's going up, the position of the projectile is going up, minus gravity because it's opposite direction from naturally gravity, multiply time. Result VOY is 100 minus gravity 10 and time is 5 seconds. So the result is 50 meter per second. And after that, so you have the result of component of velocity. V in x-axis is 103 and in y-axis is 50 meter per second. So how much is B? How much is B? How much is B? B, velocity in B equals to, using Pythagoras, is VBX square plus VBY square. Ya enggak? Ya kan? Ini vektor. Ya, like this. Nah, this is vector. So you use Pythagoras. VBX square plus VBY square root of. Diakarkan ya. Equals result VBX is 100 root 3 square plus 50 square. Result root of root 3 square is 3. 100 two times. Okay, you have, okay, so 2500. The result is root of 32500 meter per second. You can write until here, that's okay. or you want to make it more much simplified, that's okay as well. Okay, so this is the result. So next you have, okay, the next questions is the components. Of, beside component velocity, you have position of the projectile. The position h in here, how much? Okay, because again this is in y-axis position, you use accelerated motion. H equals to VO multiply t plus minus half gt square, remember? Okay, so the position using this formula, H equals to VO times T because it's in going up position, minus, because it's opposite gravity, yeah, half GT square. Don't forget, you must use initial velocity in y-axis. Why? Because h in here in vertical, exactly vertical axis, but VO, if you only use initial velocity, is like this. It's making an angle 30 degree kan, so it's not correct. So you must use in y-axis as well. That's why we use VOY. VOY is 100 times is 5 minus half gravity 10 times 5 square. So the result is 500 minus 125. So the result is 375 meters. So this is the result. Okay. So we have 375 meters. Next, other questions, point C. The time when the projectile reached the peak of its path. Okay, this is the maximum height. Okay, the maximum height in y-axis. You must find the time to reach the peak of its path. Time in here. How much is it? Okay, okay. Let me draw again the paths. Let's say it's good. Let's say it's perfect. Okay, the maximum position is in here. Check this out. In here, what do you have in here? What do you have in the maximum point? Let's say C point. You have velocity in here, VC, but also you have VC in y-axis, and also VC in x-axis as well. Yeah. Somehow you can make VC like usual again, like before. VC equals to VC in x-axis, VC in x square plus VC in y square, because this is the maximum height or the peak position. Remember, the highest position, the maximum velocity in the highest position is 0. Nah, because of that, VC in here, the the velocity in C point, you can write VCY 0, so VC x square plus 0, so meaning VC velocity in C point equals to VC in x-axis. Okay, this is the condition in maximum height. the concept. So how about time? How about time? You have h, the maximum height. For finding time of maximum height, you can use this formula again. Phi t equals to phi o minus gt with y-axis in here. So final velocity in y-axis must be 0, and for initial velocity in y-axis is 100 minus gravity 10, and time, we are looking for the time. So time is 100 divided 10 is 10 seconds. So for reaching the maximum height, we need 10 seconds. So what is the formula to find the total time? So not the total time, the time for reaching the maximum height. Okay. Time for is, you can use this formula. Time equals to V O Y over G, or you can open the formula of VOY, that is VO sin theta divided gravity. So this is the formula, time for reaching the maximum height. Where do you get it? From linear motion formula, from last meetings. Okay, that's time. Next, the next question. So you got the result, timing, you need 10 seconds. The height of the peak. Okay, how much is the height? How much is the maximum height? So this is C, ya kan? For D, the maximum height equals to, you can choose the formula, maybe you can use this. How about this one? Yes, you can use this formula as well. You can use this formula, or you can also use this one. Do you remember this formula? Phi t square equals to phi o square minus 2gh. Nah, you can use this formula as well. So final velocity in maximum height in y-axis is 0, equals to phi o, y itu sin theta ya, don't forget, square minus 2gh. So you move 2gh on the other side, become positive. VO square sin theta square. So h will be VO square sin theta square divided 2g. Okay, this is the formula for H maximum. For maximum height, you can use this formula. So how much is maximum height? Okay, I will use this one, yeah. VOY square over 2G. So make you so the result will be made faster. VOY is 100 square divided 20 will be how much is it? 1234 over 20 chat will be 500 meters. Done. Next, you have point E, the time required by the projectile to reach a height of one-fourth its maximum height of the flat. How much time? One-fourth. Point E, time for reaching one-fourth from maximum height. Meaning is how much is it? 125 meters for reaching 125. The time, how much is the time? So you can use the formula from linear motion. I think this one, that you have h and you find time as well. Yeah, okay, good. So you can use h equals to VO multiplied time minus half gt square of VO. Don't forget in y-axis for the h is 125 and this is 100 time. Yeah, you are looking for the time in here. Half gravity is 10 and time square 125 equals to 100 time minus 5t square. Okay, so in bahasa this is pemfaktoran. You change this position first, become one line. So this will be like 5t squared positive minus 100 time plus 125 equals to 0. Okay, let's divide it all of those by 5. So this will be time square minus 20 time sorry, t square minus 20t plus how much is it? 25 equals to 0. How much is it? Okay, now for this one, you need to, in bahasa is pemfaktoran, time minus how much and time plus how much. So you got two results. The first one will be positive and the second one will be negative, meaning there will be two condition in here. Positive time positive, meaning the object is going up, and if you have the time in negative one, meaning the position is going down in here. Okay, but I don't know how much is it. If pemfaktoran from, if you multiply become 25, if you plus or minus become minus 20. Okay, check this out by yourself, yeah, how much you got. Next, continue. Point E, the time required by the projectile to reach a height sorry. Oh, point F, the time by the projectile to reach the ground again if the ground is flat. Okay, so point F, you are asked to find the total time from the very first time the projectile was shot until the projectile reached the ground again. This is very simple. You already know the time for reaching the maximum height until here. That is 10 seconds, right? That is 10 seconds. So on the other half, you have another 10 seconds. So the result is 20 seconds, correct? Yes. Or you can use the formula in here. I will introduce you with the formula. Point E, point F. Time for uh, reaching the ground again. Reaching the ground again. Or we can say time for maximum distance. Because you already know that the time for reaching the maximum height is VO sin theta divided gravity. So until reaching the ground again, it's twice times. So the time in here equals to VO sin theta over gravity 2 times or times 2, yeah. So this is the result. So the answer is 2 times 10 second equals to 20 second. Okay, clear. Point G. What is the last question in here? The last question in here, you have the range of the projectile. Range of projectile, or we sometimes we say the maximum distance with symbol R. Okay, R, okay, it's equals like this. V equals to S over T, right? So S is V multiply T. So S in here is like R with the different symbol but the same meaning. R equals to V times T. But V, because the max distance in here is in x-axis, so velocity must be x-axis as well. So Vx is, don't forget, VO cos theta times T equals to VO is, how much is VO? 100 cos theta root 3, yeah. With total time is 20. So the maximum distance or the range of the projectile is 2000 root 3 meters. Clear. Alright, all done. So again, the conclusion, you have the range, the maximum distance with this formula, R equals to Vx times T. You have time for maximum distance is 2 um, initial velocity sin theta divided gravity, and also you have maximum distance is VO square sin square theta divided 2g, and time for reaching the maximum height VO sin theta over gravity, and again you have velocity in B, C, D, E, and etc. is factor of the root of VBX square plus VBY square, for example, like Pythagoras. Okay. Oh yeah, one more. I have one bonus for you. Free. If you have a VO cos theta and time in here, you can use this formula. But if you don't have time in here, you can use this formula actually. VO cos theta. Time is 2 VO sin theta over gravity, like this one, yeah. So The result is initial velocity square 2 sin theta cos theta divided gravity, and in trigonometry 2 sin theta cos theta equals to sin 2 theta. Over gravity. So you have one more bonus from me, the formula of distance r, VO square sin 2 theta divided gravity. Okay, so you already got the solution from the velocity, total time, horizontal range, maximum height. Okay, that's all from me for today's meeting. I hope you enjoy this video. You can understand more about this one, parabolic motion. Actually, all of the concept already explained by me, and your facts now open page 3 and 4 from the previous paper that I distributed to you. To try to answer those questions, you can search in Google, you can open book, you can ask me, you can ask your friends. So many researches to help you solve the questions. Enjoy your rest of the day, and thank you so much for your attention. I'm so sorry for all of the mistakes and all the imperfections. Thank you so much. See you next time. Assalamualaikum warahmatullahi wabarakatuh.